All right, guys. Today we're gonna talk about the revolution, and not just a war revolution, but the green revolution. On top of that, I'm going to include the nitrogen cycle and the all-important Haber process, among other things, and how humans affect the nitrogen cycle. So we talked about last period that clean air has about 78% nitrogen. This nitrogen is completely useless to us, even though nitrogen is a very important element because it's used to make amino acids and DNA, right? But why is atmospheric nitrogen useless? Let's take a look. Nitrogen. Nitrogen is a diatomic molecule. It is two nitrogens bounded by a triple bond, which means there's one sigma bond and two pi bonds up there. All right? Let's write this out so you can focus on this image. Right. Now, what happens is that when we break bonds, bonds are not going to be broken. All three bonds are not going to be broken completely, especially when you don't have enough energy that will force to break the bond. So we might break the bond, one of the pi bonds, and what you notice is that there are two other bonds that will keep the molecules, that will keep the element nitrogen stay together. And so naturally, what will happen is that the electrons will form the bond back again. So what if you break the two pi bonds if you have enough energy to break them? So you will see that the sigma bond now is a stronger bond. It will keep the two diatomic nitrogens stuck together and new bonds will form. So what you need is something really, really strong that can sever the bonds right in the middle so that nitrogens will split up, right? And so in nature, there really isn't a lot of things that has that kind of energy. But there are two general things that you can take into consideration. The first one being lightning. When it's thunderstorms and there's lots of lightning, what you see is that lightning is a form of high energy. You go sever the triple bond, and nitrogen is going to react with other things in the air because the lightning is also going to bring all kinds of compounds up in the atmosphere. And nitrogen is going to form, to react with hydrogen, which will be caught in the precipitation as it goes down into the soil. All right? So once in the soil, it becomes an ammonium ion, which will form salts with some other anion compounds. All right? That's not important. We're going to focus on the nitrogen. And nitrogen is going to be converted into nitrites by nitrifying bacteria. All right? And it's going to be further converted into nitrates. All right? Nitrates right here. So now that we have nitrates, it becomes useful. But before we go to complete the cycle, let's look at another process where atmospheric nitrogen can be converted into something useful. And so on, really that does happen as well. When nitrogen, atmospheric nitrogen gets caught into by precipitation into the ground, it will leach into the ground and will find its way to nitrogen-fixing bacteria that exist on the ground, but is usually found among roots of peanut plants and its relative legumes. Okay? And these bacteria, they're going to convert atmospheric nitrogen straight away into nitrates. Nitrates now becomes useful because now it's absorbed by plants, gets converted into something useful, amino acids and DNA, right? And DNA that will make amino acids. And consumers, animals, humans, will eat the nitrogen of plants. So nitrogen gets transferred from plants to animals. When the plants and animals die, all these nutrients will get decomposed and go back into nitrates, and the cycle continues. Another method where, now we're going to talk about how humans affect the nitrogen cycle. And it really starts with the Haber process. Haber, I told you, is a guy that wanted to make bombs to kill a lot of people, all right? Because he was like, World War I, and he was like a pro-German guy, and he wanted to kill everyone. So he invented this process. He took atmospheric nitrogen with hydrogen gas that is a product of oil refinery or methane burning, or whatever you want. Okay? And you put it into a container that is high in temperature and high in pressure. 208 atmospheric pressure and 450 degrees with iron as a catalyst. And he's going to put it in this burner, and what's going to happen is that the cycle will occur. Nitrogen, remember, being relatively inert, will break and form ammonia. But not all of it will become ammonia because of nitrogen's very stubborn properties. So what you see is that 28% of the process will get converted to ammonia, but 72% has to be recycled, and the reaction has to be performed again and again and again. So it's not a very efficient process, but it's the best process that we know right now. So if you can figure out a way to convert the 28% yield to something like 50%, you'll be bazillionaire. Anyway, so now that we have ammonia, it can be converted into ammonium ions and put as fertilizers or bombs, or the ammonia can be combined with oxygen and water and goes through another process called the Oswald process, where you make nitric acid, which, if you take off the H, you will have nitrates, which are a useful precursor to make other fertilizers or bombs. So imagine if the world is peaceful and bomb-free. We will take all these nitrogen compounds and feed them to our crops, right? But humans being humans and very, say, kiasu, we will tend to over-fertilize our crops. And so what you experience is excess nutrients all over our farmlands. And when it rains, these excess nutrients will run off into the other bodies of water, like lakes or oceans. And in those lakes and oceans, you will see a type of algae that really loves these excess nutrients. It's known as like red algae. And you see the lake and ocean turn red, all right? And these algae will consume lots of oxygen. And what happens is that because now there's an oxygen depletion in these bodies of water, marine life and lake fish life, freshwater fish and lakes life, they will be starved of oxygen. And remember, especially marine life, most marine life live around shorelines and bays and mangroves. So with oxygen being depleted, you will see the numbers of marine life go down. And that is how one way we affect the environment as well as the nitrogen cycle. And we're adding too much nitrates into our bodies of water that gets consumed by organisms that we don't really care about. That's it.